Hello everyone, good evening. Welcome to Career Launcher. So, we have gone through our entire course actually by now. We have done all the five modules and we are not yet finished, right? So, today I brought some challenging questions as a bonus for you for seeing how much we can think with some little unseen sort of new kind of questions, right? So call it the challenger set. All right, so we will deep dive into questions across all the topics, and we'll challenge ourselves. That is the point. We'll look at some new variety of questions, right? This is completely a fresh set, uh, right? And it will make you think. I would highly suggest that you try the questions on your own, right? Don't just go through the discussion, don't just watch the solution, but actually try them on your own, as always, right? So that is the idea. Perfect, people. So let's start with this session where we are going to look at some new questions, right? Let's see, here we go. Now, so before we start, all of you should already be knowing about this. If you don't know about this, then CDC 2 is there on August 8th and 9th. So, well, you very well know that writing an exam, in the exam situation is an altogether different story, right? Instead of giving it at home, at leisure, or at your own, as per your own convenience, right? So this is meant to give you the real picture, right? Where you actually book the exam, you get a particular slot, you go into a test center, you go through all the formalities, right? And you see a swarm of people giving the exam along with you. So that is the real feel, right? So therefore, you should make use of it and test yourself in the real scenario, right? So with that, bookings are still ongoing for CDC 2, right? So check out the details on this link and make use of it, I would suggest, right? So chaliye, let's start with the session. Okay, here we go. First question. So please try, right? Now, so let's see. So it's a question on mixtures. Now, so here we are removing a part of the solution. You can see a 375 liters tank is filled to 80% capacity with a mixture of milk and water. Half the mixture is removed and replaced with a 20% milk solution. Now, here we cannot apply the concept of removal and replacement because we are not replacing with pure milk or pure water, but with another solution. So we have to just go through the grind, I would say, which is just track down the quantity of milk and water as we proceed. We start with basically 80% of 375, that is 300. 80% means 4/5 of 375. So that's 75, 5 cancel 75 into 4, that is 300 liters, right? So initially we had a 300 liters of solution. We want the proportion of milk in the initial mixture. So I would take, let's say, X to be the initial quantity of milk, and hence the remaining of 300 minus X would be water initially. Now, when we remove half of this, so we are going to be left with half of it. So we are going to be left with X by 2 of milk and 150 minus X by 2 of water after the removal. And then so this is what we are left with, right? And then we add, we add basically 150 only because we removed 150 liters. So we add back also 150 liters, but not pure milk, not pure water, but a mixture of 20% milk solution. So 20% of 150 is 30. So you have 30 of milk and hence the remaining of 120 of water. So finally what we are left with is X by 2 plus 30 of milk and 270 minus X by 2 of water. This reverses the ratio of milk to water. Means the ratio of milk to water, which is now at this stage, is reciprocal of the inverse ratio of the initial ratio. So milk to water now is x by 2 plus 30 over 270 minus x by 2. If I just remove that factor of 2, I will have x plus 60 over 540 minus x. Right? This upon this in the simplest form will be, so this is milk over water finally. This should be equal to, right, this is milk over water final, which should be equal to water over mixture initial, which means 300 minus x over x. So that's my equation to solve for x, right? That is what this means. So just solve this now. So we get x square plus 60x from here, this into this, equals 540 into 300, 54 into 3, 162, 3 zeros, minus 540x minus 300x, that would make it minus 840x plus x square. So thankfully, although it looked like I need to solve a quadratic, but x square cancels and I'm left with a simple equation. 840 plus 60, which is 900x, is 162,000. Two zeros can be cancelled. X is what? 180. So therefore, if I have 180 liters of milk out of 300, that is a 60%, and that is the initial proportion of milk. So if you think about this, it was it was pretty, just follow the steps, right? But everything has to be done very perfectly, right? Which means you remove the exact thing, you add the correct amounts of milk and water, right? You write that expression, and then you write the equation for the revised ratio. Well, so this was the first one. Perfect. चलिए और देखते हैं next one. Time and distance. Okay, so I hope you have tried. Let's see. A boat requires 80% more time to row a certain distance upstream as compared to rowing the same distance downstream. A certain distance means the same distance. Time is distance by speed. Distance is same, so time taken will be inversely proportional to the speed, right? Which means basically it is given that time taken upstream is 1.8 times, 80% more times of the time taken going downstream. So the relation is that since the distance is same, speed and time are inversely proportional. So the ratio of time taken going upstream, t up over t down, right? This ratio is given to us as 1.8. It should be equal to the inverse ratio of the speed. So speed going downstream divided by speed going upstream. So now this speed is, we know, in relation of or in respect of the speed of the boat and the river current. So speed going downstream is the sum of the speed of the boat and the river, b plus r. If I take b to be the speed of the boat, r to be the speed of the river current. And upstream, you're going against the river current, so you're facing resistance from the river. So boat minus river is your net speed. And this ratio is given as 1.8, or call it 9 by 5. So from here I can get the initial ratio of boat to river speed, and then we can proceed with the question further. So I'm getting 5b plus 5r cross multiplying is 9b minus 9r. So I'm getting 9 minus 5, which is 4b, equals 9 plus 5, which is 14r. 2b is 7r, or b over r is 7 by 2. So I can take from here the boat speed to be, let's say, 7k, and river current speed to be, let's say, 2k initially. These are, let's say, the initial speed. Now let's look at the question further. On a particular day, the river current becomes thrice as strong as usual. Perfect. Hence, a motorboat is used instead, whose speed in still water is twice that of the boat. So both the speed of the boat and the river change, because effectively the boat itself changes, right, and becomes a motorboat. The river current becomes also quite strong. What is the proportional decrease in the total time required for the same round trip journey? Now we have to compare the basically total time taken initially and finally. So what we can do, we can assume some expression for the distance, let's say d, right? We don't know the distance. We can write the expression for the initial time and the final time based on that. So initial time total will be the distance, call it d, divided by the upstream speed, which is 7 minus 2, which is 5k, plus downstream speed, which is 7 plus 2, which is 9k. So just look at the coefficients, which is 45 is the LCM, 9 into 5, and 5 plus 9, 14 by 45 times d by k. Perfect. Now, my speed of the river, it changes from 2k dramatically to 6k. It becomes thrice as strong. And as far as the boat, we bring in a new motor boat whose speed is twice of the boat, initial boat. So initially boat speed was 7k, which becomes, well, 14k. So now the new time taken total, we'll write the expression for that. Again, the same thing, distance by upstream speed plus distance by downstream speed. Downstream speed will be 14 minus 6, which is 8k. Upstream speed will be 14 minus 6, which is 8k. Downstream speed will be sum of the speeds, 14 plus 6, which is 20k. 20 and 8 LCM is 40. So 40 and 8 fives are 40 and 22s are 40. So this is 7 by 40 times d by k. Perfect. So this time supposedly should be less than the initial. Let me write the ratio of the two. So the new time to the initial time. So just d by k will cancel eventually, we know that, and we'll be left with just the coefficients, which is 7 by 40 divided by 14 by 45. So into 45 by 14. 7 cancels, 5 cancels, 9, 8, 9 by 16. So since the new time is 9 by 16 of the initial, so it is 7 by 16 less than the initial. 7 by 16 as a fraction is a 43.75 percentage. नया टाइम इनिशियल टाइम का 9 by 16 टाइम्स है, तो इट्स लेस बाय अ फैक्टर ऑफ 1 minus 9 by 16, 7 by 16. 7 by 16 is 43.75. Right? So again, है तो routine question, but just uh, I mean, the thing is, just like any typical CAT question, it has layers to it. First you analyze the initial statement, then you proceed with the further change in the data, then you incorporate that, and then you do the new calculation, right? So it's a layered question, right? So that's the whole point. We are looking at questions very much on the CAT pattern. We have been looking at all the way along also. Right. Okay. So people, I hope you're enjoying this and you will keep on trying. Let's see the next one. Numbers. Please try. Okay, so what is this? Let n is equal to 5 into 10 into 15 into 20. Multiples of 5 are being multiplied. If n ends in exactly 25 zeros, then what is the least possible value of r? So, right, if you think about this carefully, uh, you know, the given expression, right, from it, you can take the fives, outside separately, and then you can think about the remaining expression, right? So, first of all, try to simplify n, right? Basically, each of the terms have a 5 in it, and there are r terms, right? 5 into 1, 5 into 2, up to 5 into r. So 5 into 5 into 5 into 5 being taken common. So 5 taken common r times. So 5 raised to power r. And then what I'm left after that is basically what? 1 into 2 into 3 into 4 into 5 into up to r. That is r factor. So effectively, n is, related to the concept of factorial, but it's not just a factorial. It has some additional input of powers of 5 in it, right? An extra dose, you can say, of fives. So basically this question becomes a question of trading zeros in a factorial, but it's a different situation, because you see, in any factorial we always say that the number of zeros equal the power of 5, right? That's a basic concept. But why? You see, go to the basics. Why does any number end in a zero? Let's say 180. Why does it end in a zero? Because it is 18 times 10. It's a multiple of 10. A 10 is comprised of a 2 and a 5. To make a zero, you need 1 2 and 1 5, right? Put another way, if I say, let's say x is equal to 2 raised to 7 into 3 raised to power 5 into 5 raised to power 14, how many zeros does this number end in? To make a zero, you need 1 2 and 1 5. Since you have extra supply of fives, so the powers of twos are playing the limiting factor. So this number will end in 7 zeros. If this was instead 2 power 17 and 5 power 14, then powers of 2 are in extra supply, powers of 5 are the limiting factor. So 14 powers of 5 and 2 will combine to create 14 zeros. So the point is, whichever is the lower amongst the powers of 2 and 5 will define the number of zeros at the end of a number, right? That being said, in this case, we have an extra supply of powers of 5. Traditionally, typically, in any R factorial, the powers of 5 are always a limiting factor because we know that 2, 3, 5, 7, 11, any R factorial has the powers of all the consecutive primes. But as a prime number keeps on increasing, its powers keeps on decreasing. The powers of 3 are less than the power of 2. The powers of 5 are less than the powers of 3, and so on. But since we have an extra supply of powers of 5, so it looks like in n, it is the powers of 2 which will play the limiting factor. They will be playing the limiting role. So the powers of 2, as many powers of 2 are there, as many zeros this number will end in, which needs to be exactly 25. So basically, we need our factorial to contain exactly 25 powers of 2. So we have to reverse track which factorial contains 25 powers of 2 exactly, not more, not less. Now, here is the way to do this. There is no formula to calculate n, but there is an approximation over here. For any prime p, if we need x powers of prime p in n factorial, then the value of n is roughly given by p minus 1x. And typically, it is slightly more than this approximate value. This is an approximation of n. This is not a formula, right? So by this formula, P is 2, X is 25. So 2 minus 1 into 25, we simply get the approximate value of N as 25 itself. Now 25 is not a multiple of 2. What I'm trying to say, from 24 to 25, there is no change in number of zeros. So I should not take 25, but 26, or maybe even 28 to check that actually how many powers of 2 does 26 factorial or 28 factorial contain. Let's check for n equal to, let's say, 26. What happens at 26? How many zeros, how many powers of 2 are there in 26 factorial? So we know the concept of successive, uh, we divide 26 by 2 successively. Successive division we do, and we add all the quotients. So the powers of 2 in 26 factorial are going to be 26 by 2, 13. Keep on dividing successively. Then again 13, what you got from previous division, again you divide by 2. 13 by 2 is 6. Forget the remainder. 6 by 2 is 3, 3 by 2 is 1, 1 by 2 is 0. 13 plus 6 is 19, plus 3 is 22, plus 1 is 23. I'm short of powers by 2. If I'll go to therefore 28, 28 will supply those exactly 2 more powers of 2, because 28 is 4 into 7. So yes, it will have exactly 25 powers of 2 in it. And therefore 28 is the value required. Clearly for 28 factorial, all we need 25 powers of 2. 28 powers of 5 are already in excess, because already 5 power r itself is 28. So 28 powers of 5 वो तो यहीं से ही आ गई, right? So therefore you already have, you can clearly see there's an abundant supply of powers of 5, and powers of 2 are playing the limiting factor over here, right? So this was a little bit of a twist, right? चलिए और देखते हैं. I hope you're trying with me. Let's see next one. Okay, so numbers, is full of variety of concepts. Let's see the next one again on numbers. Well, so quite a different question we have here. The sum of six positive integers is 1000. What could be the minimum possible LCM? Interesting and different. Clearly, some kind of hidden trial process is required here. There is no formula for such a question. Uh, the information itself, I mean, it's not a question of algebra clearly. A plus B plus C plus D plus E plus F, six variables add up to 1000. So you don't have to solve some equation here. It's number fitting. It's all about figuring out, thinking of what numbers I can have, um, whose sum is 1000 and the LCM is minimum. So what's the idea? What's the thought process over here? So ideally, for minimization of LCM for a fixed sum of certain number of integers, I would typically want all the integers to be equal. सब इंटीजर्स बराबर हो तो मेरा काम बहुत आसान होगा. एलसीएम वही होगा जो हर इंटीजर की वैल्यू है. बट 1000 इज नॉट डिविजिबल बाय 6. अगर यहाँ पर 6 के बजाय 5 इंटीजर्स होते तो क्वेश्चन वाज अ लॉलीपॉप की 1000 बाय 5 200, हर नंबर को 200 रखो, एलसीएम 200 मिनिमम. बट ऑब्वियसली क्वेश्चन इतना सिंपल तो रखेंगे नहीं, राइट? सो 1000 is not divisible by 6. So the idea is fine, it's not divisible by 6, but then take your integers to be in terms of like as groupings of multiple of some common factor of 1000. For example, let me put it like this. Let's say 1000. Okay, so it's 1000. We know 1000 is 2 cube into 5 cube. Okay, it has 4 into 4 16 factors. It will have 8 pairs of factors. So 1000 is 1 into 1000. There will be 8 such pairs. Let me write all those 8 pairs. It will be 2 into 500. It will be 4 into 250. It will be um 5 into 200. It will be 8 into 125, 10 into 100, um, 20 into 50, 25 into 40. Yeah, so I've got all those 8 pairs, right? Now what I'm saying, I need 6 integers, right? So the first 4 are not useful for me because I need to have groupings of numbers, and I need to create 6 values. So since 1 2 4 5, these are less than 6, so they do, I cannot I can't cannot create I cannot create numbers which are in multiples of 200 and I have 6 such integers adding up to 1000, because I have only 5 200s with me to create 6 integers, right? So I can't create 6 integers, right? 200 5 times is 1000. So 5 integers 200 each, still there is a sixth integer to be assigned a value. So what I'm saying, if I cannot divide 1000 by 6, so I will want to group my each of the integer as a, in terms of groupings of a common factor, right? So that common factor, I can think of being, let's say, 125, and I have 8 125s. So what I'm saying, if I assign 125 to each of the numbers, so 125 into 6 750 gone, then still two 125s are remaining. So two numbers get another group of 125, so they become 250. So 125, there are 4 such numbers, 125 125 4 times, and 2 times I write 250. So with this kind of a grouping, the sum is 1000 and the LCM is 250. This is one such possibility, right? So I've thought with 8 and 125, but I can also think with 10 and 100, 20 and 50, 25 and 40. So that's the idea. That's the point, right? That at least the numbers are not having too many uncommon factors in them, right? LCM will be minimized if there are as much common factors as possible, right? So that's the theme. Let's do it 100. 10 into 100. I have 10 times 100. If I assign 100 to six numbers, I have 600 gone. 400 is remaining. I'll have four numbers to become 200 then. So I'll have two numbers which are 100, 100, 100, and I will have four numbers which are 200. Now, don't you think this is actually giving me a better job? This is much better because now the LCM is even less. It is 200, right? 200 four times is 800, 900,000. I think this is a good deal, right? 20 into 50, 25 into 40. Will that help me do better? Mm, let's think about that. If I have 50, if I think of in terms of 50s, so I have to divide, I have to distribute 20 50s. No, so think about this. You have to divide 20 into six parts. 20 by 6 is 3. I mean, 20 by 6 is 3 point something. So 3336 times is 18, and then you have two more 50s. So what I'm saying, I don't think so is this is going to do a better job, because if you do 50 into 3 times, okay, which is 150, 150, that is 150 into 6, 900. Then you have two more 50s remaining. You make two more numbers to be 200 then by adding another 50. The LCM is not a good number because there's a 150 there, there's a 200 there, and the LCM of 150 and 200 is 600. Not a good job, right? So this will not improve. And even with this, clearly, just because this 220, right, created a kind of threes and fours in it. So 50 into 3 into 4 was the LCM, which was huge. Similarly here also with 25, so 6 into 4 is 24. So 4 times you will distribute 40, which is 160, 160, 60, 160 into 6, 960. And then there's a one extra 40. So one number will have to be 200. LCM of 160 and 200 is not better than 200. So clearly 200 is our best option over there, right? So purely on question of reasoning, logic based hit and trial, right? Not a random hit and trial, but thoughtfully processed, right? How do we do this distribution of 1,000, right? So it was pure, it was, I mean, minimization, maximization, number, LCM, HCF, everything all together, right? Okay, well, so this is it. This is what we are doing. The challenger set, and I hope you're enjoying. Let's see the next one. Well, so we are here with algebra. Let's see. Okay, people. So please try. Please try. We'll discuss now. So k is a positive integer and takes values randomly. K is a positive integer and takes values randomly, so that the equation x square minus 11x plus k equals 0. So middle term, which is related to the sum of the roots, is known. So I can say for this equation, sum of the roots alpha plus beta is 11, right? But the product of the roots is not known. It is k. So this equation has real roots. What is the probability that both roots are integers? Two conditions: roots are reals and roots are integers also. So the roots are real will put some kind of a constraint on k. K is a positive integer to begin with, so it is 1, 2, 3, 4, and so on. So discriminant should be non-negative. Discriminant is greater than or equal to 0. Discriminant in this case is b square. B square is minus 11 whole square, 121, minus 4ac, minus 4 into 1 into k. 121 minus 4k should be greater than or equal to 0. K is an integer. 4k is less than or equal to 121. K is less than or equal to 121 by 4. K is an integer. So 121 by 4 is 30.25. So since it's an integer, I say we finish at 30. Right. So basically, k belongs to the set of values from 1 to 30. So for this question, which is probability based, so we have to find a sample set of k. So that sample space of k is from 1 to 30. Right. So my probability will be the favorable values of k divided by the total number of values of k. the favorable values we have to find. The total values we have got that there are 30 different values of k possible from 1 to 30. Now, as far as the favorable ways are concerned, that the roots need to be integers, right? So roots are integers, but we also know that the sum of the roots is 11, right? That is clearly known. And therefore, we can find the combinations of values possible for the roots and hence the values of k, because k is nothing but alpha into beta. It is the product of the roots, very simply, right? We know product of the roots is c by a. It is k by 1 k. So value of k is nothing the value of alpha into beta, and alpha plus beta is 11, and alpha and beta need to be integers. So what could be the values that we can assign to alpha and beta? Well, obviously they are integers. So 1 and 10, right? So k will be 10. Now you might say, sir, roots are integers. Why can't we they 0 and 11, minus 1 and 12? फिर k खुद जो है वो पॉजिटिव इंटीजर नहीं होगा, right? K is alpha into beta. So indirectly, roots are integers. They need to be positive integers, right? So therefore, 1 and 10, 2 and 9, 18 is the value of k. I mean, every combination of alpha and beta will give a unique value of k. 3 and 8 is 11, 3 into 8, 24, 4 and 7, 7 into 4, 28, 5 and 6, 5 into 6, 30. And that's all. That's all. So we have these 5 different values of k that are favorable. So therefore, the probability is 5 by 30, which is 1 by 6. Right? Favorable way is 5, out of total way is 30. Right? So we know that in algebra, this integer constraint driven questions, they are asked quite a lot, right? So that being the, I mean, you should understand how to apply the integer condition and how to count the favorable solutions based on such a constraint, right? People, चलिए, perfect. और देखते हैं. Let's see next one. Now here we go. Well, so let's see. Very interesting question. What is this? Let A, B, C, D be 4 positive integers such that A into B into C into D is 10 factorial. Mhm. What could be the minimum possible value of A plus B plus C plus D? Interesting. Now, so the broad theme of this question is, we know that when for a certain fixed product of certain numbers, their sum is minimized when the numbers are equal. But in this case, all the numbers cannot be exactly the equal, because 10 factorial, we cannot have x power 4 to be equal to 10 factorial, because the fourth root of 10 factorial will definitely not be an integer. So if it is not possible to have all the values to be exactly equal, we should be trying to make them as equal as possible. Let me explain. Let's say a plus b is 11. Let's say अभी पिछले ही क्वेश्चन में हमने देखा था a plus b is 11. पिछले क्वेश्चन में we can go back. Let's say alpha plus beta was 11, and I say alpha into beta. I mean, this is the reverse question, right? इसमें alpha plus beta constant है. Let me put it other way around. Let's say I say that a into b is, let's say, 80. Okay, a plus b की minimum value क्या हो सकती है? So now a and b are, let's say, integer. I put the integer constraint. So you see, again, if you keep the numbers as equal as possible, you will be minimizing the sum. 80 can be written as 1 into 80, but the sum will be huge, 81. If you keep it as 2 into 40, then sum will be slightly lesser, 42. जैसे जैसे आप numbers को equal करते जाएंगे, वैसे वैसे sum घटता जाएगा, right? You can see this. I think 8 into 10 is the best case when the factors are as equal as possible, and the sum of 8 plus 10, 18 is the minimum, right? So therefore, that's a broad theme. So try to keep the numbers as equal as possible. So you have to split basically your 10 factorial as the product of 4 integers which are as equal as possible. 10 factorial is 10 into 9 into 8 into 7 into 6 factorial. I mean, मुझे 6 factorial तक याद है, 720. So what I'm saying, I'm trying to express this product, right, as the product of four integers which are as equal as possible. That's the broad idea. Well, so let's try to see how we can manage that. सो थोड़ा सा एक अप्रोक्सीमेट आइडिया भी होना चाहिए कि मैं किस रेंज में चाह रहा हूँ कि नंबर्स किस रेंज में आ जाएं. सो थिंक अबाउट दिस. To get a ballpark estimate of what value of each integer should be close to around what value, I have to approximately take the fourth root of this product. Now let's do that. Approximately ये product कितना है, round about ballpark figure. 720 into 7 is 5040. 5040 into 8 will be 40,320. Round it off to 40,000. 8 factorial is very near to 40,000. Then I have 8, 10 into 9, so 90 times of that. So 10 factorial therefore is nearly 90 into 40, 360,000. Right? Perfect. In fact, there will be one more zero, I guess, because 9 into 4, 36, 360, and one more zero. Yeah. So this is roughly, there are these four zeros, and then there is this 36, 360 followed by four zeros. So because I have to take the fourth root, so 10 factorial, fourth root, power 1 by 4 is approximately 360 ka fourth root into 10. Now, 4 power 4 is 256. 5 power 4 is 625. So this 360 is lying between the two. So it's roughly 4 point something. So 10 factorial ka fourth root is somewhere around 40 something. 40, 50 की range में है. So I therefore have a ballpark estimate. I want the numbers to be somewhere in the range of 40 to 50. That being the idea, let me try to express this product as the product of integers which are in that range. Right? That's the idea. जैसे सबसे पहले मुझे दिख गया ये 10 है, तो उसमें 4 से मल्टीप्लाई कर लेता हूँ. Let me make it 40. So I've taken a 2 from here. Okay. So 2 into 9, 18 into 7 into, let me split the 720 as 45 into 18. I got a very good number already, 45. Because I can take a 45 common from here. Right? This is 80 into, this is 90 into 8, which is as good as 45 into 16. Right? Okay, so I've got two numbers, I think, which are somewhere around the range what I want, right? Now 1870 as 18, 7 and 16. इसको मैं कैसे manage करूँ, right? How do I manage this? So 40, 45 is done. Now I'm thinking of, I'm thinking 18 into, what if I do 7 into 642? That would be a good deal, right? Some in this range only. And I can take a 6 from here. So I have 7 into 6, 42. I've taken a 6 from here. 3 remains. 3 into 16, 48. I think that is as good as it can get. Right. So again, a very pure hidden trial, but with logic that I want the numbers to be as equal as possible. I approximately figured out the fourth root of 10 factorial, somewhere in the range of 40 to 50. I figured out my numbers should be in that range. And hence, these integers are definitely the most optimum ones, right? And therefore, clearly, their sum is the least. So therefore, the minimum sum is the sum of these numbers, 40 times 4, and then 5 into 7, and 8, 15, right? So this is 175, right? Perfect. So this was this one again. Very good logical maxima minima question, right? Algebra का जो हमारा concept होता है, when sum of numbers is constant, then product is maximized when numbers are as equal as possible. Other way around, when product is constant, then sum of the variables is minimized when the numbers are as equal as possible, right? उसी के around ये question based था. Perfect. चलिए और देखते हैं. Now look at the next one, people. This is a question inspired from a PYQ sequence in series. Please try this. A similar question has been asked, and I guess it was a very unique question that came. So you should enjoy doing this one. Perfect. Now let's check if you got that. Okay, so there's a sequentially of the number of bacteria. A bacterial colony initially consists of 300 bacteria. The population doubles at the end of every hour. Immediately after doubling, 100 bacteria die due to environmental conditions. So basically, there is a ongoing sequence in a kind of a recursive manner, right? Whereby in each next hour, let's say an denotes the number of bacteria in any hour, equals twice the number of bacteria in the previous hour, twice of an minus वन, उसका डबल करने के बाद एक माइनस 100 भी होगा. So this is the kind of recursive rule, right, that is followed in the sequence. So based on that, your initial value a naught, the initial number of bacteria is 300, and then you have a sequence of a1, a2, a3. You have to find which an, is such that an crosses a billion bacteria. What is a billion? 10 raised to 9, right? Not a million, not a 100,000, but a billion of them, right? So obviously you cannot manually calculate this. You have to kind of find a expression, right, for an. Okay, so therefore you have to do this. You just start writing the values of the sequence a1, a2, a3. So what is the sequence? Well, the sequence is start from 300, then it goes to, well, 3 into 2 600 minus 1 500, then 500 into 2000 minus 1 900, 900 into 2 1800 minus 1 1700. Just keep on writing few terms, then we'll understand a pattern emerging. 17 to the 34 minus 1 3300, 33 to the 66 minus 1 6300, 63 to the 126 minus 1 12500, and so on. So the point is, there's a sequence in terms of the differences. This is plus 200, this is plus 400, this is plus 800, this is plus 1600, 17 plus 16 is 33, this is plus 3200 as well, 33 plus 32 is 63, and so on. 63 plus 64 is 125, right? Just a second. 60, this should be, yes, sorry, this should be for 6500, sorry, right? 3300 plus 33 plus 32 is 6500. 65 into 2, this should be 129, in fact, right? Okay, so the point is, this is what is happening right now. Based on this, you can identify a formula for an from this observation. Like a naught is 300, a1 will be 300 plus 200. For a1 you have to add 200. For a2 you have to add 300 plus 200 plus 400. For a3 you have to do 300 plus 200 plus 400 plus 100 800. So the point is, after 300 you have to add n terms of this geometric progression, n terms of 200 400 800, right? So that you add will give you an, and that you want that value to cross a billion, right? So first we write a formula for this, and then we figure out what value of n is uh, sufficient, right? So this expression is, well, we know the formula for a gp. The formula for gp is ar square and so on. The sum of n terms is given by a into r raised to n minus 1 over r minus 1, right? That's the formula. So we just put that here in the sequence. In this gp, a, the first term is 200 into common ratio is 2 raised to n minus 1 over 2 minus 1, which is 1. Simply, so this is the sum, and we want this to be more than 10 is to 9. So now figuring out this value of n should not be an issue, because very simply, uh, 2 raised to n is clearly the huge value over here, right? In front of 10 raised to power 9, 300 is practically insignificant. So I want basically my 200 into 2 raised to n minus 1 to be greater than 10 raised to 9. Again, doing that approximation, 2 raised to n minus 1 is more than 10 raised to 9 by 200. 10 raised to 9 is 10 raised to power 6 into 1000. 1000 by 205, 5 into 10 raised to power 6. Again, if this 1 comes over here, it does not impact much. So basically, I want 2 raised to power n to be more than 5 into 10 raised to power 6. Now that's what I have to figure out. What power of 2 is going to cross this limit of 5 into 10 raised to power 6? So obviously, I can't even put this in a calculator, right? Because even the smallest option is 2 raised to power 17. Right, I can keep on doing repeated multiplication. So what I'll do is I'll take a suitable power of 10, which I know 2 raised by 10 is 1024. Round it off to 10 cube, almost 10 cube. 2 raised by 10 is 1024, is very near to 10 cube. So we have to be finding that approximate value only. Okay, just square on both the sides. 2 raised by 20 is there for almost 10 raised by 6. So I think we are now just where we want to be. If I multiply with 4, I'll be still less. I need to multiply with 8, which is another 3 powers. So I think 2 raised by 23 is what I'll need. That is approximately 8 into 10 raised by 6. 2 raised by 22 will be nearly 4 into 10 raised by 6. That will fall short. So 23 is the required term. After the 23rd hour, the number of bacteria will be nearly 8 into 10 raised by 6, would have crossed the level of a billion. Right. So, well, this was a very different question where this, how do you decode the sequence nth formula based on this recursive rule, right? That logical derivation, right? How to derive that, how to infer that, that was the crucial part over here, which we figured over here, right? Perfect. So, people, I hope you are enjoying this, and we are not yet done. Let's see the next one, and I hope you will try with me. Here we go. Now, the number of triangles that can be formed using the vertices of a polygon which do not share any side common with the polygon is 30. How many sides does the polygon have? Now, so this is a question of geometric counting, right? There's a polygon, you're trying to find you're trying to create triangles not sharing any side with the polygon. Interesting. So obviously you should try to find that in terms of the number of sides n as a formula, as an expression. So there is actually standard formula for this. You can remember this. I'll derive this. Let's say there are n sides in a polygon. Just for the sake of discussion, let me just draw some random figure, and I will not close it because I don't even know the number of sides to begin with, right? The number of sides itself is the unknown parameter over here. So something like this, right? Let's say is the P1, P2, and etc. etc. Right. So I cannot close this figure because the number of vertices itself is unknown, and that is what I have to find. How many sides does this polygon have? So the ways to find the number of triangles that can be formed using the vertices of a polygon which do not share any common side has to be done by the complementary counting approach. It is not possible to count it directly. Any triangle that is formed using the vertices of a polygon can either have no side common, exactly one side common, or exactly two sides common. All the three sides can never be common. Just think about this. You can't have all the three sides ever to be common, right? NC3 or n into n minus 1 into n minus 2 over 3 or over 3 factorial, which is 6. NC3 will be the total number of triangles. From that, you need to subtract the number of triangles having one side common and two side common. Once you do that, that is the expression that you will have. The number of triangles having one side common will be simply okay. So let me first figure out number of triangles having two side common. That is easier to understand. Two sides common will be n. Why? P1, P2, P3. Just join that. So if there are two sides common, they can only be the consecutive sides. They cannot be across two different sides, right? They must be only the consecutive one. How can I ever have a triangle where P1, P2, and P6, P7 are the common sides? You will end up forming a quadrilateral, isn't it? So if there are two sides common, they can only be consecutive, and there will be n such triangles: P1, P2, P3, P2, P3, P4, P3, P4, P5, right, and so on. Last, let's say this is up to Pn. So last Pn, P1, P2. So n such triangles. As far as the number of triangles having one side common is concerned, that has to be clear. That has to be clearly understood. How do we find that? So first of all, the common side can be chosen in n ways. Let just for the sake of discussion, let me take P6, P7 to be the common side. If it is the common side, then to complete the triangle, I need to select the fourth vertex. The fourth vertex cannot be P8, cannot be P7, cannot be P6, cannot be P5. So from the n vertices of the polygon, four vertices are gone. For each of the n ways you can select the common side, the fourth vertex can be selected then in n minus 4 ways. So this is the number of triangles, n into n minus 4 triangles having one side common. So total triangles minus two sides common minus one side common is equal to no side common, and that is given to you as 30. Just we now need to solve this. You simplify this expression and you will get n minus 4 n minus 5 by 6. Just do algebraic simplification and you'll get this. So that is 30. N into n minus 4 into n minus 5 is 180. Therefore 180 needs to be expressed as the product of three integers which have this sort of a difference of a 4 and a 5, right? Just think a little bit. 180 is 9 into 20. 20 can be written as 4 into 5. So 9 into 4 into 5 exactly matches, because if n is 9, then n minus 4, 9 minus 4 is 5 there, and n minus 5, 9 minus 5 is 4 there. So n is therefore easily understood as coming to be 9. Our polygon is a non-argon. Right, so I mean, I'm giving you a formula and I have logically derived it also. N into n minus 4 into n minus 5 by 6 is the formula for the number of triangles that can be formed using the n vertices of a polygon which are having no sides common with the polygon. Well, so this was our bonus session, right? And we're going to start our next series quite soon, so stay tuned for the same, right? We'll come back to our another series, right? And I'll see you again in the next one. Till then, happy learning. Thank you. I'll see you again.